Here's the failing exchange first, as always, and this one is recorded in the literature almost verbatim. Give the model a worked example. Roger has 5 tennis balls. He buys 2 more cans of 3. How many tennis balls? The answer is 11. Then ask a new one, same shape. The cafeteria had 23 apples. They used 20 for lunch and bought 6 more. How many now? The model, asked for a direct answer, replies instantly. The answer is 27. It's 9. 23 minus 20 plus 6. And here's the diagnostic detail worth staring at. The model isn't missing the arithmetic. Ask it to show its steps, and it gets 9. It committed to a number before the steps had anywhere to happen. Why? Look at the machine's shape. An answer comes out after one fixed pass through the layers. The same amount of computation whether the question is, what's 2 plus 2, or a 6-step problem. There's no scratchpad, nowhere to put an intermediate result, check it, and go on. All it's thinking, if it does any, has to fit silently inside that fixed pass, and then the first word of the answer is final. For lookups, one breath is plenty. For problems where step 3 depends on step 2, one breath is the wrong shape, however deep the breath. Test that, however, because the obvious patch is our ear's reflex. Make it bigger. And bigger does help. Fewer slips, more held in mind per pass. But the shape survives. A bigger model reasoning in one breath is still reasoning in one breath. We deepened it. We didn't lengthen it. Enough steps will break any fixed compute answerer. Second patch, also sensible. If arithmetic is the weak spot, hand it a calculator. But rerun the cafeteria problem and watch what the calculator can't do. It can't tell you which numbers to combine, in what order, or whether this step should add or subtract. That was never arithmetic. That's the reasoning, and there's no gadget to outsource it to. Now the move itself, and it is almost embarrassing. Ask the model to show its work. Add to the prompt, more or less. Let's think step by step, or show it worked examples that include the intermediate reasoning, not just the answer. No retraining, no new architecture, not one knob moved. Accuracy on multi-step problems jumps. This, by the way, actually happened in exactly this form, 2022, and the cafeteria example is from that paper's first figure. A prompt shouldn't be able to do that, so let's find the mechanism rather than applaud the magic. The machine still gets one pass per word, but each word it writes becomes input it can attend to while producing the next. So when it writes out 23 minus 20 is 3 before answering, it has built itself a scratchpad out of its own output. Many passes per problem, each step resting on the written record of the last. The prompt didn't teach it to reason. The capacity was already sitting in the weights, latent. The prompt bought it time, spread across tokens. Thinking, it turns out, can be treated as a quantity, something you purchase more of by the word. And this, by the way, is why a chatbot's answer arrives typing itself out on your screen, not a display flourish. The machine genuinely does not have its next word until the words before it are written and read back in. And once thinking is a quantity, common sense says, don't beg for it in the prompt, train it directly. Reward won't work the episode 12 way. A judge trained on sounds good to raters is exactly the wrong teacher for reasoning, which can sound tedious and be right. But there's a class of problems that grade themselves, math with a checkable answer, code that passes its tests or doesn't, the same self-labeling trick that unlocked pre-training, resurfacing as a teacher of thought. Reward the model when the final answer verifies, and overtraining it discovers on its own that longer, more careful chains get rewarded more often. It learns to spend time. This happened too, 2024 and 2025, the reasoning models, one of which made news by learning the behavior almost entirely from that checkable reward loop. Researchers even made the dial literal, append a wait, when the model tries to stop, and it keeps thinking. Measured accuracy rises with the forced extra thought. Let's find where it breaks, so we leave honest. Spend enough on thinking and returns diminish. then sour. The model can reason its way, at length and in perfect confidence, into the wrong place. Each step plausible, the chain as a whole lost. Episode 3's locally coherent, globally rambling failure, now happening at the level of reasoning steps instead of words. Spending more time doesn't guarantee arriving anywhere truer. Still, the constraint we carry forward has genuinely changed shape. The machine can now hold a hard problem and work at it. And that changes what's absurd to ask next. Everything it does, every answer, every plan, every carefully reasoned step, ends as text on a screen, which a human then reads and does. It can write, Step 1, check the calendar, and cannot check the calendar. So the last question of our chain asks itself, what if the words could reach the world?